Hello guys, in today's video we are going to discuss the solution of the problem closest neighbor in BST. So let us look at the problem statement. The problem statement says that given the root of a binary search tree and a number n, find the greatest number in the binary search tree that is less than or equals to n. So let us try to understand the problem statement with the help of an example. So let us say this is the binary search tree which is given to us and the n which is given to us is 24. Now the closest number which is less than or equals to 24 is 21, and that is why we are returning 21. So that's about the problem statement, folks. Now let us go ahead and discuss the solution for this problem. So in order to discuss the solution of this problem, let us take an example. So let us say this is the binary tree which is given to us and the value of n which is given to us is 24. So we need to find an element in the binary search tree which is less than or equals to 24. So let us see how we will be able to find it out. So what we are going to do is we are going to go ahead and compare the value of 24 with root data. So here if you go ahead and compare the value of root data which is 5 with 24, you will see that 5 is less than or equals to 24. Since 5 is less than or equals to 24, then we can safely discard the left side of the binary tree. So this portion we can discard it, because since this is a binary search tree and all the elements in the left subtree will be less than or equals to root of data. Now since we have to find out the greatest number which is less than 24, then the greatest number less than 24 lies in the right side of the binary search tree, because of which we will look into right side of the binary search tree. So now we'll go to right side of the binary search tree which is 12, and again we are going to make our comparison. 12 is less than or equals to 24 or not. Now here also the condition is satisfied, because of which what we are going to do is we are going to discard the left side of the binary search tree and we are going to focus only on the right side of the binary search tree. Repeating the same process again. So this time 21 is less than or equals to 24. Now since 21 is less than or equals to 24, so again we are going to discard the right side of the binary search tree and we are going to go to the left side of the binary search tree. Now in this particular case, as you can see, 25 is not less than or equals to 24, because of which our answer will be 21. So this is what we are going to return. Alright. Now let's take one more example in order to understand the problem bit better. So let's take the same example, and here in this case we would like to search n is equals to 4. So for n is equals to 4, we are going to repeat the same process, and here we will say that 5 is, we are going to check whether the root of data is less than or equals to 4 or not. Now since here in this particular case 5 is not less than or equals to 4, so because of which what we need to do is we will go ahead and discard the right subtree altogether, and then we are going to focus on the left side of the binary search tree. So here now we'll go to the left side of the binary search tree which is 2, and we are going to check whether 2 is less than or equals to 4 or not. Since 2 is less than or equals to 4, that simply means that the left subtree is something which we can discard, and we will go ahead and discard this part of the tree and we will make our search only on the right side of the subtree. Now in this particular case 3 is less than or equals to 4. Since 3 is the last node of the binary search tree, so we are going to go ahead and return 3 in this particular case. So that's the general idea, folks. Now let us see how we can conceptualize this and how we will be able to code this. So let us say there is some binary search tree which is given to us, and let us say there is some n which is given to us, and we need to find the closest value which is less than or equals to n. So now what we are going to do is we are going to compare the data of root with n. When we will compare root data with the value of n, there are two conditions which is possible here. The first condition is the root of data will be less than or equals to n, in which case let us say that this is my root. Now this is less than or equals to n. So that simply means that this part of the binary search tree, and since this is a binary search tree, all these nodes are less than or equals to n. So we don't have to worry about the left side of the binary search tree in this case, because of which we will say that my current answer is root of data, and it might be possible that within the right subtree there exists an element which is greater than root of data and less than n. So in that particular case we need to find that particular data. So because of which we are going to go ahead and set our root to root of right. So that's about the first condition. The second condition would be root of data is greater than n. So in this particular case, since root of data is greater than n, so remember we are at this root and this data in this case is greater than n. Since this is greater than n, then all the elements in the right subtree will be greater than n. So in which case we can discard this. We just have to look into the left subtree. So that is what we are going to do. We will look into the left subtree. And remember, here I have not updated my answer because root of data is greater than n. And we would like to find out a node whose data is less than n, because of which I have not updated my answer. So this is what these two conditions is what we are going to repeat until root becomes empty, and towards the end we are going to return answer. So that's about the explanation, folks. Now let us see how we have coded this in Python. So here what I have done is initially I have set the answer value to -1. If there isn't exist any node whose data is less than or equals to n, in that particular case the conditions will not be satisfied or the answer will not be updated and we will return -1. Also in the case where the tree is an empty tree, the answer will not be updated and we will return -1. Now let us see how we are updating our root and answer data. So while root is not empty, we are iterating on root and we are checking whether the root of key is less than or equals to n. If it is, then answer is equals to root.key, and root we have updated it. Otherwise, root is equals to root of left, and towards the end we are returning answer. So that's about the code, folks. Now let us go ahead and submit our solution. So our solution got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.